So, how we can twist a part multiple times and what are the current limitations of the workflow presented on YouTube? As you can see, twisted part in CATIA has quite a lot of videos from multiple users. It's the same part, it was just created by multiple accounts. As we can see, CATIA log has a video regarding this. We see over here from C-Cube a video, but this 2D drawing, the original design was created by Workbenchstuff, which is this account. But as we can see, it's not that well indexed within YouTube. I noticed that if I will search CATIA twisted part like this will be the video. So we see over 300,000 views in 4 years. So that's quite a lot for CATIA. Now, within his workflow, he made use of generative shape design workbench. And over here, he defined that multi-section with those two closed profiles and the two guide spline with tangencies applied. Afterwards, he made that a closed surface in order to have that as a solid body. As you can see, this is the same part, just that this was created entirely within part design with some help from generative shape design to define those splines. So this will be that same part according to the 2D drawing defined by Workbenchstuff. Now, let's see what are the main limitations of this approach. Is that if you want to define either the orientation of those two elements that are twisted, for example, over here I added that coincidence between those two, so that axis and the original part one. I can slightly change this, like if I will elevate that on the vertical axis, and we're gonna see that our newly part will update and will still maintain that one-time twist. But the main problem with this workflow is that we want to do multiple twists. We can do that. And this is the limitation of part design and even generative shape design, where we need to define specific sketches, splines, and work with those. So I will go to Imagine and Shape. I will hide this original design. And I will create a cube. So I will start with the X and Y plane. And I will define a cube. Let's see, I will stick with the same values. So the length will be 65, 20, and 5. So this will be 5 and 20. So that will be the part. Now, in order to twist it like that, I will have to cut the face. So I will go with face cutting with 2 cuts. And now, if I will select only a side, so like this, by holding down Shift, I will do a big trap to get all those 8 points. I will go to the rotation, and we're gonna see that rotation axis. This will be 90 on X, and if I will go with 0, I will have that one twisted, let's say, embedded within the part. So, as you can see, there are some changes. So regarding that, I should also select everything and rotate, try to match it. But we can also influence that tangency that we initially had in this part using those splines. We can add that tangent direction, and we can select, for example, for point 1, we can select that edge, and afterwards we can have that tangency and also adjust the tension for that. But now within the Imagine and Shape workbench, we can select those middle points and we can go to the attraction, and in this case the weight is set to 0, but as you can see, if I'm going to increase that, this will change that handle tension within this workbench. So if I will go to 100%, I will see that the twist will look like this, and by default this is set to 0. So that's how you can adjust that curvature tension. I will leave it like this for now. And if I want to go forward with this design, this will be the same workflow. I can just transfer this part to part design, and over here I will just need to add a close body for that subdivision surface, and afterwards I have the possibility to work with that. So we're gonna see this will be the initial part design, but now the problem is that since there are within the same part body, CATIA will see this as a final part. So it's important to have this transfer to another body to work better. So I will select part 1, insert new body, this will be part 2, and I will copy this subdivision and closed surface within body 2. Also that closed surface should be transferred over there. We see that the destination is not valid in this case, so I will just delete this closed surface from that. And now go over here, I will define this as the work object, have this closed, and we have the possibility to work with that. So if I will hide the initial design, I will have the second one. Keep in mind that if you also want to position it just like the initial design, we can do that, so it's not a problem. I can just select this subdivision. It's best to go back to Imagine and Shape Workbench, and over here we have the possibility to enable that translation. So I will select everything, all element selection, translation. We see that X will be the axis, and I will go -20. In this case it will be positive 20, or we can go even 22.5. This should be that. And as we can see, we still have to rotate everything once, so I will just select everything, go to rotation, and I will rotate everything on like this on 90. If I will go with -90, this will be that rotation. As we can see, the part is twisted in the other direction from the original design. We can adjust that by doing another rotation. So I can select over here everything, and this we're gonna see that with rotation we can go all the way from -180 all the way to +180. So we can only do one twist, and we're gonna see further along this video that that is one of the main limitations of this workflow. So if I will go to 180, it will still be the same, but in this case with 90, this will match that initial part better. And as we can see, that twist can now be influenced by the attraction. So select all the middle points, go to the attraction, and according to that weight we can further increase that. But it's still not the same spline that defines that. So we can further rotate and adjust that. But we still have that twisted part. So if I'm gonna hide the original part, I'm gonna hide the subdivision surface. This is why I also like to work with subdivision surface when there are freeform parts that are twisted and stuff like that. I find it easier to work within Imagine and Shape than to change, let's say, sketches. So we see that this is that part. We can now have this transferred back to part design, and over here I can select and define those circles. So we know that they had a radius of 5. We can have those cut. So mirror extend that. Okay, so one of the differences, if I recall from that video, his initial design had over here, so we had only 4. I made it within this part 5, so that's why it's not cutting through all. So I will just cut it by 2.5 to match this. We can do the same for the other side. So in this plane I will create that circle, radius of 5. We can also constrain this according to that drawing. It was 45. And again, we can do the same cut, so pocket as it is named in CATIA. And we still have those fillets for the sides. So if I will go with a fillet of 5, this should do like that. So a fillet of 10, this should do that full half circle. And we can just define the same fillet for the other edges without having the need to create an additional one. So we see that is the part created in part design. For the width of those, there are slight changes, and also maybe because of that the part is a little bit twisted, because our initial part only had this length of 2, and I added within the imaginary shape 2.5, so 5 overall. Okay, so now let's see, within another part body, so I'll just hide that, hide this as well. I will create a new part body, and within this one I will go back to imaginary shape, and let's see the limitations of this workflow in CATIA. I will select again the X and Y plane, define a cube. Okay, so I see that defined twice. Let's define it again. I double clicked by mistake. Okay, so defining work object, select the X and Y plane, and this should only create one box. Now I will make this slightly longer, so I'll go to affinity, and I will make this let's say 200 millimeters. I will set it to 4 and 20 for the Z. And now, in order to further twist this, I will do more cuts. So I'll come over here to the cuts. If you're gonna see that the highest number over here is 9, keep in mind that that is not the highest number. If you want more than 9, you can just come over here. For example, I will add this to 16, and now we can do that 16 cut, as we can see over here. And now this adjusted accordingly, so it's scaled a little bit lower, and we can slightly increase that. But for this case study, I will just do 9 cuts. Now I will come to the right view of the part, and I will start rotating this. So I will take everything in the middle. I will go to rotation, and on the x-axis I will go this, so round that to 0. Afterwards I will further go and get the next set of points, so I'll just reduce that selection and have those rotate to minus 90 in this case. So you're gonna see we're gonna have a twist like that. If I will go further and keep selecting those inner points and having those rotated, so we had minus 90, minus 180, you're gonna have this rotation. I will further select the inner ones, and again I will have those rotated. In this case, go back to 90, or I can go, let's say, to 0. You're gonna see that to 0 we're gonna have that self intersection, which is, it can be problematic if you want to design parts that are intended for manufacturing. If you just make some visual elements, that shouldn't be any problem. But I will not leave it like that, so I'll go to 90. And we still have the middle section to rotate once. So in this case I will take the middle selection and take it to 180. And we're gonna see that this will be how our part will be rotated. Since we only have one section in the middle, we can't fully twist that. If I will leave it like this with 0, we're gonna have a little bit of continuity to that. So now for the limitations, as you can see over here in CATIA, we can only twist it between 180 and minus 180. But in other softwares, like in 3ds Max, if you want to twist it further, for example, we see here over here 1080 for the angle, we see that this box will twist accordingly to that. So if I will just set this to 90, it will make that 90 twist from this section all the way over here. I also added some limit to this part. But if I want to further twist this, I can go to 360, or I can double that, 720, or I can go even more, or like this. And now, if I want to have this transfer, so I find it way simpler to twist objects in 3ds Max than in CATIA. But if I want to have this transferred over to CATIA, I can just select the object. I can go to File, Export, Export selected in this case because we have two elements within the scene. I will just call this twisted 1. And I will just leave it over here with the default OBJ export options, hit export. And now within CATIA, I will hide that subdivision that we defined earlier. I will go to import subdivision. And over here, we're going to have this twisted one. As we can see, it's not a large file. So roughly around half megabyte. But within CATIA, since we have so many subdivided elements over there, I'm going to see that the computer will slightly lag a bit. So I'm going to have that imported. But now, as soon as I'm not in edit mode, I have the possibility to move it around. And now I can just do the same workflow. If I want to add some fillets and some cutouts, I can do that. Again, I need to go to part design, close surface, so that will be the same workflow. As you can see, there's quite a lot of geometry over here. If you don't want this to be so high, since CATIA is struggling a little bit on my PC, we're gonna see how we can adjust those in a second. But I just wanna reveal the fact that now we can do those cuts. We just need to define those planes. And since the part is no longer oriented along with those, it's better to define some 3-point plane on this surface. Now, since this is quite heavy, if I will press F3 in 3ds Max, I'm gonna see that for the length, I have a total of 30 segments, but it's also the same for the width and height. So we can slightly adjust those. Since for the width, we only have 20, I will go over here to something like 10, and for the height, something like 4. I can go even lower. And now, if I will export this simplified version, so export selected, this will be called twisted 2. So if the other model had close to almost half a megabyte, we're going to see that this simplified element will be quite smaller. So this will be only 86 kilobytes. And we're going to see that imagine and shape will import it better, and we can also work better with this. So we see we still have that twisted part, and we can further select and rotate elements if you want to do that. But I highly recommend that you do the, let's say, most important rotation and twisting directly in 3ds Max, and you control it over there a little bit better. So let me see the axis. This should be on the Y in this case, as the model was exported like that. So you can further have those rotated. Now I also have over here this part. So since we are over here, I see that the video is 20 minutes long. I will just create that simple twist over here. So let's see the workflow. I will just define that box. We know that we have the length, we have the width, and we have the height. Now for the number of geometry, I will just leave it initially to 5, 5, and 5. And now if I'm gonna apply the twist over this, so go to modify, have that twisted. We know that on the y-axis, we're gonna go by 90 degrees. This will be that twisted part. And we can also influence the limit if we don't want some areas to be influenced by that. As we can see, this is the upper limit. So the upper limit in this case should be with a negative value. And the other one should be with a positive. So if I'm adjusting one, both will be adjusted. So I will just clear that like this. So have that limit. And now have the limit enabled. So you see now the software allows me to have one positive and one negative. And now I can just slightly increase the angle of rotation. So this is 90. I can go to 360. And as you can see, the shape is oddly deforming because there's not a lot of geometry over there, but we can change that by going to the box and we can just add more segments. So I will just set it to 20 to all, and we're gonna see that now that part will be a lot more smoother. But again, the main advantage is that we can further increase the rotation. It will be divided on the length of the part, as we can see over here. So this is a much better workflow in this case. But keep in mind that if some parts are quite small and you're gonna twist them a lot, they will heavily deform. So something like this with 720 degrees should be more than fine for a part that only has 65 millimeters. And also it's important the ratio over here, and with the ratio we see with a width and height of 20 and 5. Okay, so I hope you find this video useful. If you want to twist your parts, keep in mind that you can use Imagine and Shape workflow to further, let's say, rotate and adjust those elements. And at the end, you can just convert those into part design and it will be the same workflow over there. Okay, so I hope you find this kind of content useful. If so, please let me know in the comment section. And also consider to subscribe if you want me to create more additional content. Thanks, remember to stay creative, and see you in the next video. Bye.